In this tutorial, we will learn how to do a horizontal heat exchanger design with GLD. I've already opened the Average Block Loads module, imported my loads, and selected a heat pump. If you have questions about these processes, please view some of the other tutorials. The next step is to open up a horizontal heat exchanger module. I can do that by hitting this button. The next step is to link these two modules together so they communicate back and forth. We can do this by hitting the link button here. We can see that there's a pink light down here and a pink light down here indicating the two modules are communicating. The next step is to design the heat exchanger by going through these tabs one at a time. We'll begin with the Fluid tab. Here we can enter the entering water temperatures. These are the temperatures coming out of the ground loop and going into the heat exchanger. Going into the heat pump. They impact both the heat pump performance as well as the length calculations. I'll select an entering water temperature here of 92 degrees. And for heating, I'll select a temperature of 35 degrees as a starting point. You'll note that when I change the temperatures here, they also change the temperatures here, impacting the pump performance. Our design system flow rate will leave at 3 gallons per minute per ton, which is a standard. And for the solution properties, I'll hit automatic entry mode, I'll stick with propylene glycol, and I'll choose a freeze point of 25 degrees so that I have protection beyond the lowest target temperature of 35 degrees. Now in the Soil tab, we can enter our ground temperature, our undisturbed ground temperature, as well as our thermal conductivity and diffusivity. The program comes with a range of soil tables that allows designers to quickly estimate the conductivity and diffusivity for a certain soil type if they have not done a quantitative thermal conductivity test. Finally, at the bottom, we can enter information related to ground temperature corrections. The software is able to model how the soil temperature is changing at shallow depth throughout the year. This is critical for optimal sizing of a heat exchanger. Here we can put our regional air temperature swing, as well as our coldest and warmest day of the year. The coldest day in this case is 37, meaning it's around February 8th, which is around the 37th day of the year, and 219 is in midsummer sometime. If you have questions about swing temperature data, you can hit this button. Now the Piping tab is where we can specify the type of pipe and the flow rates. And the Configuration tab really is the heart of the heat exchanger. In this tab, we specify the number of trenches and the pipe configuration in each trench, as well as the modeling time period. You can think of the trench layout as also being a row layout. A lot of times people will do a pit excavation and just have rows of pipe. So think of this as a trench or a row of pipe in a pit. For the time being, we'll start with 25 trenches or 25 rows of pipe. We'll aim for a 10-foot separation. We'll go for a 12-foot depth. This width is for references purposes only and is not used in the calculations. Now the next step is choosing the pipe configuration in the trench. We can have a single row of pipe, 2 rows of pipe, which is like a U-tube or a horizontal bore, 3 rows of pipe, a vertical slinky, or a horizontal slinky. We'll go with the horizontal slinky for now. And we'll specify the modeling time period of 1 year, which is a standard for horizontal systems. Here we can enter extra kilowatt information if we have it, as well as general project information, which is included in a range of reports. We go back to the Results tab and hit Calculate and look at our design. Looks like we have a total trench length of about 6,000 feet, 25 trenches, where each trench is about 250 feet long. The total pipe length in this design is about 82,000 feet, because there's lots of slinkies, there's a lot of pipe length in it. If we wanted to, we can continue optimizing our design by modifying some of the parameters. And we can do this by clicking on any of these tabs here, double-clicking to expand the user interface. Then we can see all of our design parameters here that we can modify. For example, I could move the trench number up to 30, hit Calculate again, and see that each trench length drops to 200 feet. This concludes the general introduction to designing a horizontal system with GLD.